Hello, my name is Ayush and this is my submission for Simulink Student Challenge. In my project, I will investigate the application of Simulink and MATLAB tools for a comprehensive analysis of fault detection in underground cables utilizing the frequency response analysis combined with machine learning techniques. Let's set up a foundation for underground electric cables. They are revolutionizing the power distribution by providing enhanced reliability, safety, and aesthetic appeal, while significantly reducing maintenance cost and the risk of outages caused by severe weather condition or external damages. If there is a fault in cable, then the time required in finding the fault location is high by using the traditional method. Traditional methods like thumbing and time domain reflectometry have long been the backbone of fault detection in underground cables, offering reliable yet labor intensive techniques that often struggle to keep pace with growing complexity and demands of modern electrical infrastructure. Much work regarding the reduction of the time required in finding the fault location are already been done. The work done includes finding the fault location through wavelet analysis, computer vision, and Fourier transform and model transforms. Calculation of the frequency response analysis involves evaluation of the system's output to sinusoidal inputs, where the steady state response is characterized by its magnitude and phase, allowing for efficient identification of system behavior and potential faults in underground cables. As there are very limited research available on the topic of frequency response analysis of underground cable, therefore my goal in this presentation is to demonstrate the system including the underground cable setup along with the frequency response setup for finding the fault location accurately with the help of the Gaussian process regression model. Following are the models which I have created using different Simulink blocks for making my simulation successful. This is the model prepared by me, which illustrates the project as follows. The two subsystems are used to demonstrate the 10 km long underground cable, and this short circuit is done so as to get the faulty data from that. This subsystem includes a nominal pi system, which helps to represent the underground cable and uses the data like this. A supply of 20 volts is given through this AC voltage source block, and this faulty data is then gathered with the help of this current and voltage measurement blocks. The gathered data is then given to the Fourier blocks, which helps to convert the data into magnitude and the phase responses of them. This magnitude and phase response data is then given to the divide and the subtract block, which in turn gives them to the workspace in the form of a spreadsheet, and then the scope is used to demonstrate the final graph of the data. After running the code, the scope results into the following output of the graph, which shows us the fault condition at different distance, for example at 1 kilometer, 5 kilometer, and 9 kilometers. After running the code, we get the two datasets. One is for the magnitude response of the system and another one is for the phase response of the system. This both the responses are then combined to form the training dataset, which is the final one. The fully developed training data is then given to the regression learner app, and then the model with the least RMSE validation is picked up. Here it was Gaussian process model. Once the model is trained with the training data, the model is exported as code and it is checked with the help of the testing data. Now you can see the code of the model. This code is then used at the command window to find out the prediction of the model, how accurate the model is.